So, we've talked about converting between grams and moles. We've talked about moles and molecules. Now we're going to talk about volume, because you can actually convert between moles and volume as well. Volume's in liters, right? So we're going to have a new conversion where we go from liters to moles and moles to liters, okay? Now, one thing with this is it's a gas, and if you change the temperature of gases, they expand or contract, right? If you have a balloon, you put it in the freezer, it would get smaller. You take a balloon and you carefully heated it up, not so that it doesn't, you don't want to heat it up too much because it'll pop, but if you heat it up, it'll expand more, all right? You can see this on a cold day if you put a balloon outside, that kind of stuff. Okay, so because of that, because the temperature is important, we need to define a standard temperature and also a standard pressure, because gases, you can compress them as well. So we need a standard for all this. So in this chapter, we're going to keep all of our calculations at that standard. In later on chapters, things will change a little bit, but for right now, we'll use the standard temperature and pressure, which is abbreviated STP, all right? And that's pretty much what it says here. The volume of a gas varies with a change in the temperature or a change in your pressure. Because of this variation, the volume of a gas is usually measured at a standard temperature and pressure. So, what is STP, or what is the standard temperature and pressure? It's, temperature-wise, it's 0 degrees Celsius or 273 Kelvin. And the reason we're talking Kelvin is because you usually use Kelvin with gases, all right? Gases like Kelvin. And we're going to talk about that a lot more later on when we get into the gas chapter. But there they are. And then pressure-wise, you can have 101.3 kilopascals. That's one version of pressure. There's also something called an ATM, which stands for atmospheres. So it makes sense that the standard would be there's 1 atmosphere above us, right? So that's kind of how things are. How do you increase atmospheres, or how do you increase pressure? Well, if you go underwater, right? If you go down 10, 12 feet, you'll start to really feel that pressure. So right here, well, if we were at sea level, it would be about 1 ATM as air pressure goes. And the other one besides kilopascals, ATM, would be 760 millimeters of mercury. And this is used in a mercury barometer. And we'll talk more about that when we get to the gas chapter as well. But for right now, you just need to know the numbers. And we'll talk about more of what they mean later on. Because honestly, in this chapter, everything is going to be at STP. So then you can just convert the liters to the moles without really having to think about this at all. Okay, but I wanted to give you a little background on STP. Okay, is everybody okay with that? Yep. Okay, so 1 mole in liters. So at STP, 1 mole of any gas, now this is cool because it doesn't change for the molecular mass of it, any gas, all right, occupies a volume of 22.4 liters, okay? Now if you think about 2-liter sodas, right, 1 bottle of 2 liter, so that's obviously 2 liters, right? So you would need 11 2 liters of soda. If you filled that up with a gas, that would be a mole of that gas. So gases, they say they expand, right? If you have a liquid of something, when it becomes a gas, it expands. That's how much it expands. If we had a mole of water, we could hold it in our hand, right? But if we had a mole of water vapor, which is water turned into a gas, then it would need 11 2-liter bottles of soda that have been emptied and then put water vapor in them. Does that make sense? Actually 11 and then some because of the 0.4. So that's a lot. All right, so that's how gases expand a lot. This is known as the molar volume of a gas, and it's measured at STP. All right. So as long as we're at STP, in this whole chapter we have our mole flow chart where we had moles and grams. We had molecules with formula units. We had atoms. We had our shortcut if it was one element, you know, you can go straight there. But now we're going to add our volume. All right, so we have volume here. And now it's just going to be 1 mole equals 22.4 liters. All right, so we just added a little bit to our mole flow chart. All right, that's it. So this was 1 mole equals the molecular mass. This was our 6.02 times 10 to the 23rd. Whatever it is, in this, we'll just say molecules in this case, was 1 mole. Going from molecules to atoms, this was 1 molecule equals the number of atoms. All right, so molecular mass, yeah, everything, and then this is 6.02. It's 10 to the 23rd atoms equals 1 mole, and it only works with elements. All right, so that's only for elements. Okay, so that's our mole flow chart. Now we added one more thing here, right? Everybody's okay with that? So in this chapter, we're not just going to be converting things from grams to moles and then moles back to grams. We can do any of this stuff. You can go from grams of one thing into moles, switch the moles around to something else, and then go to volume. Or you can go to molecules, or you can go to atoms. So it will get a little bit more complicated, but it's basically all the same stuff we did last chapter. The only new thing is that mole switch that we just learned, and then this new conversion factor. Good?